Alright, function operations. First example, we're going to add and subtract functions. F of x is given to you. Everything in black up here is given to you. F of x equals 3x plus 8. G of x equals 2x minus 12. Find f plus g and f minus g and their domains. It helps when you write this out to use parentheses. Addition, it doesn't really matter if you use parentheses in adding them, but it does matter over here in subtraction. When you add the two functions, all you do is combine like terms. What's 3x plus 2x? 5x. What's 8 minus 12? Negative 4. Find their domains. What type of function is this? If you were to graph it, what would it form? It's a linear function and form a line. The domain of any line with slope is all real numbers, because what is domain?
X value.
X values. Alright, so what X value is included on any line that has slope? All of them. Okay, that's why the domain is all real numbers. Over here, this is where I was talking about it helps if you put parentheses, because you need to distribute the negative. You have to subtract the whole thing. What's 3x minus 2x? 1x. 8 plus 12 is 20. So x plus 20 is your answer, and it's, again, linear. Your domain is all real numbers.
So whenever you have an x in the answer, it's going to be all real numbers.
If x is your largest variable, yes. Okay, if it gets into a...
So when is it all real numbers?
When it's a linear function right now. All we've got right now are linear functions. But we're going to get into others right here in the next example. Alright, next example. F of x equals x squared minus 1. G of x equals x plus 1. Find f times g. That dot is multiplication, and f divided by g and their domains. So the first one, in order to multiply f and g, you had to FOIL, which is what I did. You end up with x cubed plus x squared minus x minus 1. You have a cubic function as your answer. We've already graphed some of these cubic functions, and you should know what they look like. If you don't, you can just type this straight into your calculator and get an idea of the shape it takes. Alright. From the graph, you should realize that it's all real numbers, because the curve continues to go into the negative axis and the positive axis. All right. If you're ever unsure of what the graph is going to look like, type it into the calculator, and then you can figure out the domain easily. Over here, in order to divide, we need to simplify both the numerator and denominator if possible. You can simplify x squared minus 1 because it is factorable. This falls into the difference of squares formula. Factor x squared minus 1 to x minus 1, x plus 1. Divided by x plus 1, what happens to the x plus 1s? They cancel. You're left with a linear function again. X minus 1 is your answer. What's your domain for any linear function?
All real numbers.
All real numbers. Except in this case, x cannot equal negative 1. Why can x not equal negative 1? Any idea?
Because you have the square of even root.
No. What happens if I plug negative 1 in right here?
Oh, 0.
You can't have 0 in a denominator. That's why it cannot be negative 1. So anytime anytime you have a denominator, you need to look at it, and that would be your exception.
Kushner,
Yeah.
all real numbers does all real numbers include 0 also?
All real, yes. All right. Next one. There are a couple ways to write this. The book uses FOG. That's a composition of functions. The last example is composition of functions, where we're putting them together. It's not multiplication. All right. I like the red. The red is the same saying the same thing, but I think it's easier to understand when you see it in red rather than f(g). It's asking you to evaluate f of g of x. So basically, if you're looking at the red here, here's f of x, x minus 2, g of x equals x squared. But let's go back before we go on to this. If I told you to evaluate f of 3, what's your answer?
3.
Negative. No.
1.
1. What's f of 12?
1.
10.
10.
What's g of 9? 81. All you're doing is plugging in the number I tell you
using
to
that now.
for x, using these two functions. All right.
Plug the number
So I'm
in.
telling you what to plug in for x. Okay. So again, g of 9 would be 81 because 9 squared is 81. So here they don't give you a number; they just give you x. So it's telling you to evaluate f of g of x. We know what g of x is, right? What is g of x?
G times x.
What is it though?
X squared.
X squared. So just replace x squared for g of x, which is what I did here. You see that? Now I'm going to evaluate f of x squared. That's telling me to plug x squared in wherever you see an x. So your answer is x squared minus 2. So you take whatever number's in the parentheses and plug it in for x. In this case, x squared's in the parentheses, plug it in for x. Okay, it's a lot easier when you're dealing with numbers, which we get into the third one. The next one, g of f of x. We know what f of x is. What's f of x? X minus 2. So g of x minus 2, I plug x minus 2 in for x. So I had to square it. So I FOIL, and I end up with x squared minus 4x plus 4. Okay? And like I said, the numbers are a lot easier. Evaluate f of g of negative 3. What's g of negative 3? Positive 9 is negative 3 squared is 9. And then you do f of 9, which is 7. So what would, let me throw one more out there. G of f of 8. Quickly. G of f of 8. No. 36. G of f of 8. F of 8
minus 2 is 6.
is 6. 6 squared is 36.